Hello, in this short video I'm going to solve the following problem for you. Let a star be the binary operation defined on R by, for all x and y in R, x star y equals to the cubic root of x cubed plus y cubed. Show that R forms an abelian group under the binary operation star. Pause the video at this point and give it a try. Okay, in order to prove that R forms a group under the binary operation star defined in that way, I have to check the axioms of group structure one by one. The first, I have to convince myself that this is indeed a well-defined binary operation, meaning that R is closed under this binary operation. But that is easy because if you give me two real numbers, then it is clear that the cubic root of the first number cubed plus the second number cubed is still a real number. But what is this? This is nothing except x star y by the definition of a star. So this means that x star y belongs to R. So this means that if you give me two real numbers, arbitrary real numbers, then I showed that the result of the star of those numbers is again a real number. So this means R is closed under this binary operation. The second axiom is the axiom of associativity. It means that if you give me three arbitrary real numbers, I want to convince myself that there is no difference between doing a star between x and y first and then star it with z, or a star y and z first and then x star on it from the left. I want to convince myself that this is indeed the case for any triple of numbers x, y, and z. Okay, so we can calculate the left-hand side and the right-hand side and compare them. Okay, so I can calculate the left-hand side, but how should I calculate that? This pair of brackets prioritize this star first, because I have two star operations, but the pair of brackets prioritize this first. But x star y is nothing except what you see here. So I would write the third root of x cubed plus y cubed, and then after this I have a star z. So I copy and paste it here. But how should I continue? I have to be able to interpret this in a correct way. X is the first number, y is the second number. The first number is star, the second number is interpreted or defined in this way. The cubic root of the first number cubed plus the second number cubed. But here this is my first number and this is my second number, and I want to star them. So according to the definition, it becomes the cubic root of the first number cubed. The first number is itself a cubic root. The first number cubed plus the second number cubed. But this third power will cancel this third root. Okay? But of course this bigger one will survive. So this becomes the cubic root of x cubed plus y cubed, and then I have z cubed. Of course, in principle I have to put a pair of brackets, but you know that addition operation is associative, so I don't need it. Okay, let me also write it properly. So yes, this is my left hand side. The right hand side can be done in a similar way. So I copy and paste x star because now a pair of brackets is around the second pair, so it means the second star has priority. So I will copy and paste x star, but instead of y star z, I use this definition to write it down. This is my first number, this is my second number, so this becomes the cubic root of the first number cubed plus the second number cubed. Now this is my first number, this is my second number, I want to star them. So according to the definition, it becomes the cubic root of the first number cubed plus the second number cubed, but the second number itself is another cubic root. Yes, I can make this smaller a little bit. Okay, so now, oops, I forgot to put this 3 here, so and it's a 3 here. Okay, but this power of 3 will cancel this third root, that the bigger third root will survive. So it becomes the third root of x cubed plus y cubed plus z cubed. Again, of course, I have to put a pair of brackets around them, but it is not needed because addition is associative. And then now compare. The left-hand side is equal to this. The right-hand side is equal to the same thing. So it means that the left-hand side and the right-hand side are equal. So this means yes, this I can guarantee that this is also the case. The next step is to prove the existence of the identity element. I simply claim that number 0, the real number 0, is the identity element. To support my claim, what should I do? I have to convince myself that x star 0 is equal to z star x is equal to x for every real number x. I have to convince myself. But that is extremely simple. If I, for example, want to do x star 0, I have to use the definition of star. This time x is my first number, 0 is my second number. So this becomes the third root of the first number cubed plus the second number cubed. But this becomes simply the third root of x cubed. But because 3 is an odd number, the answer becomes x. And of course you can simply check that this one is also true. The next step is to guarantee that every real number has an inverse with respect to the binary operation star. Now again, I claim that for every real number x, the inverse is minus x. How should I prove that? I have to show that x star with minus x is equal to minus x star with x, and it is equal to the identity element, which in the previous case I proved that it is 0. So I have to convince myself that this is indeed the case, but that's also very simple because x star minus x, according to the definition, becomes the cubic root of the first one cubed plus the second one cubed, but the second one is minus x. And then because 3 is odd, so then it becomes x3 minus x3, and this becomes 0. Similarly, I can prove that this one is also true. So this means every real number, the inverse of every real number with respect to this binary operation is minus x. Okay? The last one is, so far I have shown that R with a star forms a group. But now the problem asks you to prove that this is an abelian group, so I have to show that this operation is also commutative. And that's also very simple. So if you give me two real numbers, and then when I calculate x, y, star y, this becomes the cubic root of x cubed plus y cubed, but you know that addition is commutative, so I can replace y cubed and x cubed. But now if I ask you what is this expression, this is nothing except y star x. So this means that for any pair of arbitrary real numbers, x star y equals to y star x. So this means that this operation is also commutative. So therefore, R together with this binary operation forms an abelian group. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.